Okay, well, shit. I guess I forgot it resets at 5. So we solve another one for today. Although it looks the same as the one I just solved, it's maximize the number of target nodes after connecting trees to. There exist two undirected trees with n and m nodes, labeled from 0 to da da da. You're given two 2D integer arrays, edges, and such as an adjacency list. And this is the different one, it looks like. Node U is a target to node V if the number of edges on the path from U to V is even. Really? Note that a node is always target to itself. Return an array of n integers, answer, where answer I is the maximum possible number of nodes that are target to node I, or of the first tree if you had to connect one node from the first tree to another node in the second tree. The queries are, okay, so we need to draw this one again, MS Paint, and then so for I equals 0, so we have our first tree. Let's just, I know this is going to be a fuck ass. We have 0, 1, 2, and then I'm not going to bother with the circles, yo. And the most optimal way to connect these is connecting it to 0 again. Right. Um, nice. Okay. And there's 3 connections. 1, 2, 3. 1 goes to 4, which itself has 5 and 6. 2 goes to 7, and 3 is by itself. So after connecting it, at node 0, we have awesome sauce, dude. We have, it's even, so these 3 nodes are out of the picture. These 3 nodes are out of the picture. And then it's just 3 and 4, so 1, 2, 3, 4, 5. These are 1, 2 edges away. And then this is 3, these are 3 edges away, so, and then this is 4, so ba ba, so we have 1, 2, 3, 4, 5, 6, 7, 8 nodes. So, okay, it seems like we're gonna have to follow the same pattern as the previous problem. Although, I guess I'd like to solve this coming from the point like I've never seen a problem like this before. So I will say that um, whenever we have a node I in tree 1, whenever we want to add it to a node in tree 2, we get the number of nodes that are an odd distance, I mean even distance away from I. So in this case 0, there's 2 nodes in tree 1 that are an even number away. And then we'd have to add that to all the nodes in tree 2 that are an odd amount. And for every node, I think we have to flip this on its head, because when we connect it to another node, the distance increases by 1. So I would have to, so for here 0, I would actually want to count the number of nodes that are a odd length away. Yes, an odd length away, like here, here, here. Okay, nice. So I think I will do that. So just like a lot of graph. Well, this is a tree problem, but it's like a special type of graph. So I'll say graph. A lot of graph problems. We're gonna just make our adjacency list, and we'll call this one like T1. Sup sup. I love Tyler 1. So we'll say int n is equal to edges 1, right? Oh, plus 1 because they're numbered from 0 to, what is it? Because, right. And then there's going to be n nodes. So it's going to be edges m is equal to edges 2 dot length plus 1 array list n list integer t2 is equal to new array list m. And honestly, for this problem specifically, I could honestly see a BFS maybe being more efficient, because then we could just skip a whole like level. But I think I'll still just use a DFS because that's just easier for me to write, in my opinion. And then we'll just construct our adjacency list. So for int edge, edges 1, these are undirected, so we need t1 Jesus 0 dot add edge 1, and then 2 directions. So we add it for this, and then we'll do this for the second tree, which is edge 2. Right. Okay. Trees are built. What do I do now? That's a good question. So, like we said before, the max amount of things is the number of even distance nodes in tree 1 plus the odd number of whatever our connecting node is. So we need to pre-compute all that. So I need to make a function that nice. Okay. Cool. Cool. I mean, like, okay, I could probably find a way around like the odd counting in the DFS, but we'll figure it out. Okay, we built our our adjacency list graph, and then we want to say we need a int t1 dis equal to new int n, and then int t2 dis is equal to new int m. Well, let's just call these count. I think count is a better name. I know it's a little nitpicky, but where count of I is count of odd slash even slash odd distance nodes from a node I. Right. And then we need to actually fill these. So for int I equals 0, I is less than n. Okay, I'm gonna just write the DFS first. Public int DFS int u list integer for my life. Do I just want to make 2 DFS functions so that one of them is just even and one of them is odd? I think I do. Right? I think I do. Yeah, I'll figure it out. Let's just call this adjacency, and then I need a set, right? So boolean set equal new boolean math.max mn. I'll reuse this for this one too, so why not? Boolean set, and then let's just say like int dist. So how do I go about doing like a full-on DFS from each node? Awesome sauce. Oh, I feel like there has to be a way to optimize this using like DP. I solved one where it's like, get the distances of all the nodes when you're moving. It's like, dude, but I don't want to do that. Let's say int, ooh. We could say like int res is equal to 0 if dis remainder 2 equals 0, if it's even, res plus plus. Otherwise, for int v in adjacency u, we can say if set u, we'll do another DFS of from v adjacency. Oh, we probably want to say set of u is equal to true as well. We want to visit this. Set and then distance plus 1. And then we'll say res is plus equal. And then we'll return res. And cool, DFS2. Aha. This is probably not great to do in real life, but I'll do it because I don't feel like adding another. I feel like this is somehow easier than adding another thing. Trust? I'll test both. I'll test both. Then we'll say t1 count of I is equal to dfs1 from I, dfs1 from I, adjacency, set 0. And then we'll say raise dot fill set false. This is probably faster than making a set to a new array, I think. And then we'll do the same thing for adjacency t1. We'll do the same thing for t2. Right? And then I don't know, int res is equal to new int n. And then for int I equals 0, I is less than n, I plus plus, I plus plus. We'll say that for int j equals 0, j is less than m, j plus plus, I'll say like int cur is equal to -1, then cur is equal to math dot max cur, and then t1 count I plus t2 count j, and then res I is equal to cur, return res. Oh. Oh. Oh wait, I didn't fill the array list. For 0 I is less than n, I plus plus t1 I is equal to new array list. And then we'll just copy this for t2. Course, what's wrong with you this time? Oh, because you should be t2 count. That's not good. Hey. Okay, before we tweak anything, let's see what's going on. Then arrays dot toString t1 count. Let's do the same thing for t2 count. I should be studying for Spanish. Oh, well, that's not good. Why are you doing that? That should not be it. Mm, 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 right when lying upside down. So it looks like it's doing this, and then when it gets here, oh, dude, dude, what I, oh God, wait, will this submit on first try? One must believe it does not time limit exceed. Time limit exceeded. Hey. Okay, so this is the idea. I can do it, but it's just not efficient enough. Cool. Would it be more? Uh, mm, is it because of this? Maybe? Oh, I wouldn't even. Yeah. Okay. So how? Damn it. See, I'm so close, but if I just submit again, it will work. Okay, wait, let me read the description. Okay. 0. Wait, can I just get the most? Max2 equal to -1. Max2. Max2. Can I just greedy say this? And then, like, I'm gonna. Shit, I don't want to delete all of it. We'll say for int I into 1 count. Wait, well, I want to say for int I equals 0, I is less than n is plus, count is plus equal max to return t1 count. I'm going to use this as a test case too. What? Oh, t1 count. I. Oh, is it gonna still be time limit exceed? Shit. Wait, does it work for this? Okay. Okay, now I'm curious if I could have done that for the previous problem, because in the previous one I did the double check, but maybe I could have just been greedy about it. Add. Okay, I guess I could have just done that. How much did that That didn't even make my thing more efficient though. Although I guess in hindsight it makes sense. Okay, this one is just variable for some reason. And the graph for this one looks really weird. Okay, that's crazy. Oh, I didn't play music. That's why I didn't submit correctly. So how do I... Is there DP in this? I really hope there's not DP in this. Hmm. Maybe I'll go back to a previous... Oh, well, maybe not there. That is soft. Difficulty is hard. Topic is tree. Okay. Maybe this one. Wait, let me... There's not even DP in this one. Wait, how am I... Why am I time limit exceed? Yo. What possibly could I do to make this more efficient? I'm literally so close. Maybe I think I need a hint. That's what I did. What? Wait, that's actually what I did. That's bar for bar what I did. Unless I did something so obscenely wrong. Is it this? Is there a better way that I could have done that? Like, I don't know. Like, is there even... Like, that one just straight up used DP. But... Cool. Oh, I guess maybe it is a tree. Wait, hold up. It is a tree, so I would just have to keep track of the previous node and make sure I don't... So this is probably just redundant then. Prev. Maybe that's why I'm time limit exceeding, because of this. Okay. It's still time limit exceeded. So it wasn't that. Wait, what? What in my code could be so terribly inefficient? Nice. I don't know what's wrong with you. I don't know what's wrong with you. Wait. Dude, is there a way for me to compute that more efficiently here? Wait a minute. No, that wouldn't work. Dude, I'm so fucking close too. Well, now I kind of want to try that for this problem too. I think that would make it even better. Improv. Okay, awesome sauce. I'm so I'm fucking done, dude. What do you want from me? Bro, dog. Like, do I actually have to use that fucking thing where I shift here and the number of nodes? I might have to look at the solution, dude. Node use. Fuck. Okay. So clearly we can't just brute force. We can't just brute force and keep the distance to compute. So maybe I need to see a relationship between the nodes. This might be a two-parter, yo. Fuck. I guess I technically solved it, and it's just not efficient. I guess because of the condition that it's only even nodes, then I have to abuse that somehow, right? Can I say that so at 0 fuck. Okay, I will do 10 minutes. Okay, 1 hour is crazy. Just fucking leak. I'll do 10 minutes. If I can't finish this in 10 minutes, then I'll look at the solutions. So, for any node U, these nodes would be an odd distance away. But any node that is an odd distance away from an odd distance node is even, right? Because 5 plus 3 is equal to 8. Proof by duh. So if I keep track so could I just compute the number of wait a minute. Let's get rid of this test case. Cause the amount of we saw it earlier when we printed it that wait, hold up. So we saw earlier that when we printed this out, oh, yes, there's only two, there's gonna only be two types of, there's only gonna be two distances for any node. And that is, so I would only have to compute it once and then use that answer to fill everything in. Because, look, wait, the piano! Look, if we look at this graph, including 0 itself, there are two nodes that are odd distance away from 0. And all of those nodes, and these nodes, this node would have the same amount too. The same distance. It's only nodes that are an odd distance away from the original node that would that's only an odd distance away. So I would only have to count the amount of even nodes once. And then keep track of all the number of nodes that are odd. Because we can say that, because if DFS1 is equal to even node count, then odd node dist, so like any node that was Wait, wait. I understand it now. Okay, okay. So n int evens is equal to DFS 1 0 t1 minus 1 and then like 0, and then I'd have to mark, so I would say boolean odds equal int n for all to note if odds is oddest away from 0. Right. Else odds u is equal to true. Odd is equal to n minus evens. I understand now. Ha, I understand now. Wait! Why am I smart? Am I? So if the number of odd nodes is equal to the amount of evens minus... Right? And then for int I equals 0, I is less than n I plus plus, res I is equal to odds I? Evens. Wait, no. Odd. Evens. This is really bad naming convention, but it's okay. And then it's the same thing. Five, 3. So we'll say int add is equal to math.max right. Wait, is equal to math.max. We want to get the odd number from... Okay, so we'll just say df is 2 from edges to 0, 0, right? T2. Honestly, we could just say like 0. No, this somehow seems better. Edges 2, 0, 0. T2. T2 prev minus 1 0. Oh wait, we'd still need a and then DFS2 edges to 0 1. So these are two adjacent nodes, so one of these will return like an even odd number, right? Oh my god, 30 seconds. That's a good point, Java compiler. Oh, that's a good point, Java compiler. That's a good point, Java compiler. Wait, this can't be. No way! Wait, I think I'm actually good at LeetCode now. Well, I went a little over 10 minutes, but solved hard. Wait, 5 plus 3 is equal to 8. Oh my god. Oh, hopefully what I said made sense. I forgot I'm doing this so I can actually do good at interviews. Oops. Good luck.